looking at this problem, we have a nonagon, and we have some information about that nonagon. In fact, this one's going to be a little bit easier for us because of the information that we're given. The one thing we really didn't go over yesterday is that we can, I mean, obviously with right triangles, we have enough information. We can use Pythagorean theorem if we like. We're told a nonagon has a radius of 10. So the radius is 10. And the side length is 6.84. Which means if I draw in my right triangle, this is going to be half of 6.84, 3.42, right? Now, I don't need to use SOHCAHTOA or anything here to find that third side. The third side of my triangle is the apothem of the triangle. I mean, the perimeter I already can get. Perimeter is just 9 times 6.84. And I have no idea what that is off the top of my head. Anyway, it's a little less than 90. No, it's a lot less than that. 61.56. Okay. That's the perimeter. All I need really is the apothem here, and that's going to be just Pythagorean theorem in this case. So I don't have to do anything really fancy. I don't have to use SOHCAHTOA. I don't need to know the angles even. I can just use Pythagorean theorem because I have enough information. So 3.42 squared plus a squared is 10 squared. So a squared is 100 minus 3.42 squared. So 100 minus 3.42 squared is 88.3036. I take the square root of that. Gives me 9.4 approximately. Or 9.396, 9.40 to 2 decimal places. So 9.4. Once I have that, I could find the area either way I want to. I could find the area by finding the area of this triangle. This times this divided by 2, doubling it, and then multiplying by 9, because there are 9 such triangles. Or I could use perimeter times apothem divided by 2, so 61.56 times apothem of 9.40 over 2. And that's probably what I would do. Gives me 289.3 approximately. If we did it the other way by doing the triangle method, we take 9.4 times 3.42. Base times height divided by 2 is 16.074. I double that to get the area of this triangle. So that's 32.148. And then multiply that by 9, because there are 9 triangles, and we get exactly the same answer to 3 decimal places. Okay? So we could do it either way, but the key was using Pythagorean theorem to set up that triangle. That was our best bet there. Because we knew 2 sides. If we know 2 sides, finding the third is just easy. Okay? Yes? Yeah, you could, we divide by 2 to find the area of this triangle, then multiply right back by 2 to find the area of this triangle. So, yeah, we could actually skip that whole thing by just doing this times this, and that'll give us that area of that larger triangle and multiplying by 9. So if you can handle that shortcut in your head, that's fine. Okay. I just hesitate. Some people still forget to divide by 2 when they're finding the areas of triangles. I don't want people to get in the habit of not dividing by 2 and finding the area of the triangle. Some people are still struggling with that. No names. I didn't say any names. Oh, I'm sorry. I looked in the direction of the class, and you happened to be there, yes. Other questions in the homework? Okay. Let's just take a look at a couple other problems then. And this is similar. Find the area of this septagon. Again, use the unit shown. Give it to the nearest tenth, the area. How are we going to do that?
Carefully.
We're going to use Pythagorean theorem to find the third side, aren't we? Okay, so 2.5 squared plus x squared equals 2.77 squared. Again, those are numbers I'm not going to know real fast, but if I find that out, 2.77 squared minus 2.5 squared is 1.4229. Take the square roots of that. It's about 1.19. And from there, again, I could either find the area of that triangle, double it, and then multiply by 7 because there are 7 triangles, 7 sides. Or I could use that to find the perimeter. And again, it'd be simple. I'd double it and multiply by 7. So we're really doing a lot of the same things. That's why one is as easy as the other. It doesn't matter really which one you choose. And then multiply that by the apothem divided by 2. I'm going to find the area of the triangle this time. So 1.19 times 2.5. I divide that by 2, and then I multiply it by 2 again, and I get that this triangle here is about 2.975 for the whole thing. So times 7, 20.825 is the area. Now it said the nearest tenth, so I'd say 20.8 meters squared would be the nearest tenth. So make sure we round it appropriately. Okay. This is a little more interesting problem. Find the area. It's an equilateral triangle. And all we're given of the equilateral triangle is the apothem. So we have a little bit of work to do. But again, in an equilateral triangle, they aren't so bad because each triangle inside here, I mean, obviously each central angle, 360 divided by 3 is 120 each, right? So this angle here is going to be 60, 30, and 90. So if this side of the 30, 60, 90 triangle is 8 centimeters, right there, how long is the hypotenuse going to be? And how long is this side going to be right here? Okay, so how long is the whole base going to be? Whole side? 16 root 3. I've got everything I need now to find the area of this triangle. I could do it a number of different ways. I could just do the whole triangle base times height divided by 2, because now I know the height. I mean, this is 8. The radius is a constant, so this is 16. The height of this triangle is 8 plus 16, or 24. So I could take base times height divided by 2, and that would be the area of the triangle. So I could take 16 times 16 root 3 times 24 over 2, which would be reducing 12. 12 times 16, I should know that off the top of my head, but I'm going to check it. 192 root 3. That's one way we could do it, base times height over 2. Another way we could do it is we could do it by building it up from small triangles to large triangles. We could take 8 times 8 root 3, which is 64 root 3 divided by 2 is 32 root 3. And then this is 32 root 3 over here also. That's 64 root 3. So 64 root 3 times 3, because there are such 3 triangles like that, is 192 root 3 centimeters squared. So that's way number 2. We could do that by building from the small triangles up to the larger triangle. Another way we could do it is I could use side squared root 3 over 4 is the area. That's the formula for area of a triangle, the 1, 2, 3, 4 we learned yesterday. The side is 16 root 3, so that's 16 root 3 squared root 3 over 4. Now, order of operations says exponents first. So 16 root 3 squared, 16 root 3, and then square it, is 768. Divide that by 4 is 192. So it doesn't matter which method we use, we get the same answer all three ways. I have a lot of choices when it comes to working with my equilateral triangle. But it all comes back to, can I solve this 30, 60, 90 triangle here in the base? Can I get the solution for that? And I do need to know how to solve 30, 60, 90 triangles. You are going to see that show up again on your quiz, just like we had last time. Find the perimeter and area of this octagon. The apothem is 9 centimeters. That's all we're given. Okay? Well, let's find it. Let's find it. We're going to start by trying to find our triangles. I need to know this angle so I can find this side. Whoops. That side down there. If I can find that length there, I can find the length of a side and multiply that by 8, and I got the perimeter, right? But I still need to know either this angle right here or this angle up here. One of those two, I know this is the right angle. How can I go about finding this angle, the vertex angle up there? That's a small one. What do I do? Well, again, I think of the central angle for my octagon. What's that central angle have to be? 360 divided by what? 8, because there are 8 sides, which is 45 degrees. Take 360 divided by 8, that's 45. So that's 45. What's this angle up here going to be? Half of that, 22.5 degrees. Yep. Don't round it to 23 degrees. Do 22.5. Be precise. Well, now we're golden because I've got the apothem. I need this side here, which is which with regard to the 22.5 degree angle? Opposite, what function am I going to use? So tangent of 22.5 is x over 9. X is in the top, so 9 times tan 22.5. Tells me that side is 3.73. And I double that to get the length of a whole side, because that's only half. Whoops. Not times 2. So 7.46, I multiply it by 8, because I need the perimeter is 589.68. Okay? So I found my perimeter now. Solve one little right triangle, one side of one little right triangle. Now I've got my perimeter. My area is pretty easy. It's perimeter times apothem, which we were given, divided by 2. So take that times 9, divided by 2, 268.56 centimeters squared. So again, it really comes down to, can you solve the triangle? Now this time we had to use trig because I only knew one side of the triangle. In a lot of the examples we had in the beginning hour, we knew 2 sides. This time I only know one side, so but I do know an angle, so I have to use trig. And really that's about it for today. I mean, we just keep, your next screen press will be a right click. Well, that's wonderful. I just had a right click. I'm really excited about that. Not. All right, so what we're doing today, again, just kind of working on this and practicing, and if you weren't practicing yesterday, you should be definitely practicing today. Oh, here we go. We've got page 765, 19 through 28. Actually, make it 19 through 25. 36, 47, and 48. So 19 through 25. 26, 27, 28, or 20. 26, 27, 28 require us to work with circles, which we haven't done yet. So 19 through 25. Then that. Tomorrow, just so you're aware, tomorrow I'll be gone. Ms. Johnson will be here. Mrs. Johnson will be. And it's going to be like last time. You're going to be working on reviewing for the next quiz. We're going to do it the same way we did it last time. Your partner up, same partners you had last time, person who sits across the aisle from you. If somebody is absent, then work it out. If everybody is here, then Courtney will probably have to join a different group as a third, okay? Because otherwise you got everybody paired up with twos. So it isn't just kind of pick your own. I kind of want you to be specifically with those people otherwise. I think it works better when you're not necessarily with your bestest still friend in here. Well, then, but for you guys it seems to work okay. But anyway, just keep that in mind that that's kind of what we're going to be doing tomorrow. And it's review, and then it's actually the test on Friday. And there's going to be a homework on Friday, too. You might want to jot that down right now, the vocab that'll be due for Monday. Get that jotted down right now so you have that, because I won't be here to put that up on the smartboard for you. Yeah, kind of curious about that. No.